We are continue to speak in this part about soil fertility management and exactly about soil properties. We will continue to speak about soil properties in this second part of the lecture, Soil Fertility Management. I'm the Professor Jawair Dulia. I'm continue to be again with you during this part and in the other parts of this lecture. As I said, soil fertility management. Speaking about soil properties, now I want to speak to you about soil color property. Soil color is important because it indirectly shows how rich or how much the soil contains minerals and how much organic matter is in it. Because the color depends on minerals that are in the soil and on the organic matter content. Different soils and their horizons have different colors, as we saw in the previous part of this lecture. But it's not only this. Color itself can influence soil temperature. So, influencing the soil temperature, in fact, it can influence the plants that can be grown there and the plant production and plant development. Soil color is typically described using some form of color reference chart, such as the Munsell color chart. Which one will you see on the right side in the photo? It is easy to evaluate the type of soil in a given area based on the color of the soil in the field conditions. Another property of soil is soil texture. Soil texture refers to the proportion of the soil particles that make up the mineral component of soil. These particles are called sand, silt, and clay. These soil particles have the following size ranges. Sand has from 2 to 0.05 millimeters size of particles. Silt has between 0.05 to 0.002 millimeters, and clay, which is the most teeny part of the soil, has particles lower or smaller than 0.002 millimeters. This classification of the soil based on the particles is according to United States Department of Agriculture classification. From the other side does exist other particle size classification, but the logic is the same. The only one that change is the range or the size of the soil. Collectively, the soil particles of sand, silt, and clay are called the fine earth fraction and represent inorganic soil particles less than 2 millimeters in diameter. Inorganic soil particles 2 millimeter and larger are called rock fragments. Sand and silt are the inactive part of the soil matrix because they do not contribute to a soil's ability to retain soil water or to retain soil nutrients. These particles are commonly comprised of quartz or some other inactive minerals. Clay has a large amount of surface area per unit mass, so it has a larger surface for the same mass of particles, and its surface charge attracts ions and water. So, clay is the active portion of the soil matrix. Clay is an important part of the soil matrix. For all mineral soils, the proportion of sand, silt, and clay always adds up to 100%. These percentages are grouped into soil texture classes, which have been organized into a textural triangle. But why soil texture is important? Soil texture can affect the amount of pore space within a soil. Sand-sized soil particles fit together in a way that creates large pores. However, pore space created by sand is a relatively small amount of total pore space. The clay-sized soil particles fit together in a way that creates small pores. Overall pore space from clay there are higher than the pore space created from the sand-sized soil particles. A soil made of clay-sized particles will have more total pore space than a soil made of sand-sized particles. And as a conclusion, or consequently, clay soils will generally have lower bulk density than sandy soils. And here in this photo you see a triangle. It is the triangle of the soil texture. It is an important tool that helps us to define the soil texture. But before this, we have to do sampling and do analysis in the lab to define exactly the percentage of clay, silt, and sand in the sample. After we have defined this and have calculated their in percent to the all sample, then we try to find where this percentage of clay, silt, and sand meet together, and exactly the point where they meet together, it defines the texture of the soil. For example, if we have the percentage of the clay 50%, we have to go here in the vertices of clay and find the number 50, and from it we follow a line that is parallel to the sand percentage. Then if the content of the silt was 30%, we do the same thing, go to the silt vertices, find the number 30, and follow the lines that is parallel to the clay. And then the percentage of sand will be 20, so we follow the line, first finding the number 20 in the sand vertices and go parallel to the vertices of silt. So where they meet together. So 50 from clay, 30 from silt, and 20 um, and 20 from sand, we have the texture of the soil. And in fact, in this case, we have a clay soil. If we have another, let's take another example. Okay, let's take that we found 30% of clay. The same procedure, 30% of clay, so means the other difference of 70% is silt and sand. Let's suppose that we had 30% of sand, so 30% of clay and 30% of sand. See where they meet together. And then we have 40% of silt, and they all meet together here. And in this case, we have a clay loam soil. The first one that we defined previously was a clay soil. This is not a clay soil, but it is a clay loam soil, and so on. So this is the way how we define, with the help of soil texture triangle, the soil texture. Here in this slide, you have a YouTube link. You can click on it. In fact, you cannot click directly here because it is transformed in a video, but you can copy it from here and then go to the YouTube channel, or you can go to the file with links, with a list of the links where I have introduced this link to. So, till the next time, I wish you good work. See you in the other part of the same lecture that is dealing with the soil properties. Bye bye.